How is radioactive material detected? Radioactivity is the emission of ionizing radiation from unstable nuclei. Ionizing means that this radiation is energetically capable of detaching electrons from atoms in matter. The ionizing property is the basis for the great majority of the technologies developed for detecting radioactive material. The earliest methods simply relied on watching for photographic film to fog in the absence of visible light, or watching for an electroscope to discharge. You can build an electroscope from simple materials and instructions that are abundant online. In this case, radiation ionizes the air that normally insulates the charged conductors in the electroscope, causing its discharge. In the modern world, there are a wide variety of specialized detection technologies that address particular needs. For example, workplace safety in industries using or generating radioactive materials, detecting the proliferation of nuclear weapons, testing homes for radon, dating samples in archaeology and geology, or diagnostic imaging in nuclear medicine. Geiger counters, scintillators, proportional tubes, semiconductors, and of course, modern variants on the old electroscope are some of the most frequently used detection technologies today, and variants of these serve the examples mentioned above. Although each technology has specific advantages and disadvantages, all rely on the basic fact that radiation from radioactive materials causes creation of free charged particles by ionizing the medium. For more depth, please look up Glenn Knoll's excellent textbook, Radiation Detection and Measurement. The term, radioactive material, just means equipment, parts, or items that have been exposed to gamma or neutron radiation from a nuclear reactor and/or may have radioactive contamination on it. I'm assuming that you were really wondering how radioactive contamination is detected, and the answer is the same way regular radiation is detected, a radiation meter, but with a much more sensitive probe. In the biz, we call them friskers, since we use them by moving the probe slowly about a half-inch from whatever surface it is you are surveying. This could be anything from the floor to the skin on your arm. Friskers can detect even the most minute amount of contamination. This is how we ensure personnel are not contaminated when they finish work on a radioactive system, or handle radioactive water. These radiacs measure radiation by counting the number of electrical signals generated by incoming radiation. These electrical signals are generated by photointeractions between electromagnetic waves, radiation, and matter. How is radiation detected? As a radioactive material is just a material that emits radiation. The short answer is that it is done indirectly by looking for byproducts of the radiation interacting with the material of or within the detector, and that no machine detects all forms of radiation. Different particles at different energies have different probabilities of interaction depending on the material it is possibly interacting with. This concept is completely different from the tangible world. In the tangible world, if A is stationary and B is heading directly at A and B will collide. In the particle world, ignoring the electromagnetic force, there is only a probability that B will collide with A, and that probability depends on what A is and the energy of B. Because of this, radiation detectors are designed for certain types of particles and have limitations on the energy ranges of the particles it can detect. As far as your question about how this detection is done, the simple explanation would be through example, an ion cloud chamber detector is used primarily for gamma-ray detection. The chamber is filled with air and there is a central wire running through the center of the chamber and is charged along with the walls of the chamber, so an electric field exists between the wire and the walls. When gamma rays enter the chamber, can pass through the walls BC of the probability thing, charged particles such as protons and electrons will not be able to make it through the wall BC. Their unique probabilities cause them to be far less penetrated. Thus most other particles are shielded. If the gamma ray interacts with the air in the chamber, in most cases, an electron is liberated from the atom the gamma ray interacted with. This free electron now gets caught up in the electric field introduced by the central wire and the walls and is then pulled towards the positive side of the electric field and collected. The collection of these electrons generates a current and thus you have an electrical signal. This is the same basic electrical signal electronics run on, and the signal is read. You have successfully detected radiation.